Hey there, everyone. I'm pretty sure you can tell just by looking at the slide that today's lesson is on random samples. So we're done with our geometry unit, and we're going to end the year with just a few lessons on statistics and probability. I am going to actually refer back to the Ready book today, so we haven't looked at that for a while. So there are two main learning targets here. First of all, understanding that random samples are a way to gain information about a whole population, and then considering the difference between random samples and biased samples. All right, so let's take a look at the book. All right, so like I said, this is lesson 26, understanding random samples. And the question here is, how can you use samples to gain information about a population? All right, so they have an example here of a food service company that supplies meals for 12 different schools. The company wants to get information about students' favorite lunches. So surveying every student in every school would take a lot of time and effort. So they're looking at a way to be more efficient. And the way people do that is they just choose a random sample that represents the whole group. So they would just take a random sample of students, and then they would use the information from that sample to make decisions about the whole population and their favorite lunches. All right, but it's very important that a sample be chosen that does represent the entire school. So this is an example of a couple of different scenarios. The one on the left would be representative, the one on the right not. And I think you can see why. Like over here on the right, they've got everything like organized, nice and neatly. Maybe this would be like organizing students by grade level. And over here, everything is more random. And since they're choosing like just a particular circle here, the one on the left is going to be more representative. So I would say this one is random. This one here is biased. And it's really because of the way they're choosing things and the way they've got things lined up. All right, so I'm hoping that makes sense for you. So here is the situation. Here's how you really decide if something is random or biased. In order for something to be considered random, every object or event has to have an equal chance of being selected. Right? If a survey is given to the sample group, then the ratio of each response to the sample size should be approximately equal to the ratio of each response to the size of the entire population. Right, so once a random sample is truly taken, then in order to make an estimate about the whole population, you can see we're setting up some proportions and ratios here. Here's another way to think about it. So the percentage of people giving each response in the sample should be about equal to the percentage of people who would give each response in the entire population. So we'll be talking again about ratios, proportions, and percents just a little bit. Okay, so let's take a look at this. Let's say this is the way somebody decides to question kids about, I think it's still about lunches. All right, let's say this jar contains the names of all of the students at center school. All right, well, if you look at this top scenario, it says, suppose you pick 10 slips of paper from the top of the jar. Well, maybe the slips that are at the top of the jar are just from the last class, then that's going to be biased, all right, because it doesn't represent the whole population. All right, so the second paragraph gives another option here. Suppose you put your hand in and mix all of the slips up every time you pick a name, right? Well, with that method, then the names do get an equal chance of being selected. That would be a random sample, right? And then they give you a few options here for ways to collect a random sample. So one, you could use a pattern, such as selecting every fourth person who enters the cafeteria. You could use a method, such as drawing names out of a hat, where everyone has an equal chance of being selected. Or you could divide the population into groups, such as by grade level, and then randomly select people from each group, right? As long as you have an equal number from each grade level. I think that actually works quite well. Right? These are some ways that could result in biased samples. Letting people volunteer. All right, that's always going to be biased because people with certain interests are going to then take the survey. Choosing people who are easy to reach, such as students who happen to be in the cafeteria already. All right, that's not going to be random because that's not giving everybody in the whole school the equal chance to take the survey. Or choosing people as a group, such as students on the honor roll. All right, so that's not really right either. Again, it doesn't give everybody an equal opportunity. All right, before I go back to the slideshow, I want to show you this right here. Let me go back to the beginning here. This is kind of an interesting thing. If you've got a lot of students that you're trying to survey, or let's say you're trying to survey a lot of people in the city of Portland or something like that. So random.org does this. You can actually have it very quickly randomize a set of numbers. So one way to do this would be to assign everybody in the school a number and then randomize it and then choose the top 30. You'll see in a minute why I'm choosing the number 720. All right, so I'm just going to have it be in one column. All right, and then a sequence is great because a sequence does not repeat numbers. And in a situation like the one we're asking for, you don't want it to be repeated. Spreadsheets actually do a really cool randomize feature. You can actually set spreadsheets up to also randomize and not repeat a number. I'm not taking the time to do that today just because that's a little bit more complicated, but anyone who likes spreadsheets, check that out. All right, but on this one though, it's just so much quicker. So I'm going to hit get sequence, right? And then it gives me all 720 numbers in a random order. So if I was going to choose 30, I would just choose the top 30 because the computer program already randomized it for me. Then let's say somebody chooses not to take the survey, then you can just do the next number down. But this is kind of cool. All right, let's go back to the slideshow. So what we're going to do is we're going to start by looking at a couple of problems and just see, oh, well, how does this work then if you get a random sample? So for the first two problems, we're not even going to try to consider whether it's random or biased. We're going to assume that these two examples that we're talking about are random. All right, so Carla has a list of all 720 students in her middle school. She writes the name of each student on a slip of paper and puts each slip in a box. Then she pulls 30 names from the box to determine or to decide who she will survey about the upcoming school election. All right, so it's like she's taking the first 30 from the list and she's going to survey them. All right, if 5 students in Carla's sample of 30 say they plan to vote for James in the school election, how many students in the entire school do you expect will vote for James? All right, so this is a time when proportions work really well. So if you'd like, go ahead and pause the video and see if you can figure it out. Okay, so one thing I did is I thought, well, this might be a good time to set it up as a fraction or set it up in a box. So I decided to set up a little table. So the sample size is 30. The total population is 720. And then 5 out of my sample said they'd vote for James. So then I'm trying to figure out, all right, in this box down here, would be then how many then in the total population would vote for James. All right, my table's not set up that great, but I'm just doing it to figure out the answer. All right, there are a couple of ways to do that. One way is to say, all right, well, 5 is 1/6 of 30, or 30 divided by 6 is 5. So I could do 720 divided by 6 to get this number. Or I also know that 30 times 24 gives me 720. So I could just do 5 times 24. That's another way to get that number. All right, so let's see what it is. All right, it's 120. All right, and if you just think about the math that I just did, that would make sense. So then I would expect that 120 students would vote for James. Now remember, this is always an approximation. It's never going to be exact. But if Carla truly did have a random sample, then her answer is probably pretty close to accurate. All right, let's take a look at this one. Caitlin did a survey of 200 randomly selected gym members and found that 72 of them are interested in yoga classes. The gym has 1,000 members. About how many gym members would be interested in yoga? All right, so consider using percents on this one. 200, 1,000, those numbers that end in zeros really work well in terms of working in percents. All right, so I figured it out this way, but again, there are several ways to do this. It's like, okay, 72 out of 200. So I just did 72 divided by 200. That gave me the decimal 0.36 or 36 hundredths or 36%. But you guys, 72 out of 200. Maybe a quicker way to do that would just be to divide 72 in half, because it's really, the percent would be out of 100. So half of 72 is 36. In fact, that's the way I did it in my head. 36 out of 100. So then 36% of the 1,000. So then you can see, well, 36% of 1,000 then is 360. All right, so about 360 gym members would be interested in yoga. I would love to know on your Google Doc if any of you were able to just solve that in your head. That would just be really cool information for me to know. All right, we're going to end this video with 5 different scenarios that do come from the ready text. And what we're going to do is consider whether they are random or biased. And I'll give you the book's answer. Again, I would love to know if you disagree with the book's answer. All right, so I'm going to give you the reasoning that the text gives, but again, would love to know if you disagree. Okay, so here's the first one. The events committee wants to survey students about a school dance. The committee is meeting in the gym where the girls' basketball team is practicing. They survey the players on the girls' basketball team. All right, the book says that is biased. Why? Well, because not everybody in the school gets a chance to be part of the survey, and you're only getting like just a few athletes, and you're only getting girls. All right, so biased. All right, second scenario. A store owner wants to survey customers about the products he sells. He has the mailing address for all of his customers. He programs the computer to select 100 of those customers from a mailing list and sends them each a survey. The book says this one is random, all right? And that's because they're saying everybody on the mailing list, because of the random generator, like random.org, they have the same potential of being asked to take the survey. All right, so that was what the book said about that one. All right, third one. Teachers from a school are asked to send 4 students from their homerooms to represent the class. Mrs. Rose puts the names of all the students in a box, mixes the names, and pulls out 4 names without looking. All right, the book says that is random because all of the students have the same potential of being pulled for the 4 to go to the office. All right, this one, same situation. All right, but Mrs. Burr sends the 4 students sitting closest to the door. All right, the text says that is biased because by doing that, not everybody in the room has the same opportunity to get pulled for that random sample to go to the office. Right, and the thing is, you don't know why certain students might be sitting closest to the door. There might be a reason for that. All right, so anyway, that's what the book says there. All right, last scenario. The producers of a television singing contest are conducting a survey on their website to see who viewers think should win the competition. Okay, that got worded kind of strangely, but so it's a television singing contest. They're conducting a survey on their website to see who viewers think should win the competition. All right, what does the book say here? The book says that is biased, all right? And their reasoning behind that was that not all of the television viewers are going to get on the website. Maybe they don't have internet access. Maybe they just don't want to get on the website. They just prefer to watch the television show. They also felt it would be biased because certain people who feel very strongly about who should win the competition are going to get on, and that's not exactly random. You need to have maybe some people who feel really strongly about it, others who don't. So anyway, the book said that one is biased. All right, so that is the end of this video. I'd like you to fill out the Google Doc that goes along with this and hand it in just to show that you listened to this. All right, more tomorrow on statistics.